Okay, in this video we're going to discuss how to convert between moles and particles. So first thing that we want to mention here is that the word particles is just a general term that we use to usually reference either atoms, if we're talking about singular elements like potassium or calcium or something, or molecules if we're talking about compounds, more than one atom bonded together, something like CO2, for example. Okay? We're going to look at two example problems just to get quick practice with this skill. So the first problem asks, how many moles of xenon are contained in 24 times 10 to the 24th atoms? So my given, 24 times 10 to the 24th atoms, and I'm trying to figure out how many moles. So as always, start with writing my given. So 24 times 10 to the 24th atoms is my given. And now I got to do my conversions. Okay, well, let's think about what I want my conversion factor to look like. With moles and particles, the conversion always has to do with Avogadro's number, which we know is 6.02 times 10 to the 23rd, whatever it is how many things there are in 1 mole. So in this case, we just got to think about what needs to go in the numerator and what needs to go in the denominator. Since we have atoms up top here, we need atoms in the bottom, which means I'm going to have on the top 1 mole. How many atoms are in 1 mole? Avogadro's number, 6.02 times 10 to the 23rd. Sorry, that's a little tight in there. Now, before we start doing the simplification, you'll notice that these exponents are not the same. So what we want to do is we've got to use our knowledge of scientific notation just to make a change here. We want to make these exponents the same. So I'm going to drop this down to the 23rd in order to make it match the 23rd in the denominator. Remember, whenever you lower an exponent, you're making the number smaller. Therefore, that means we have to move the decimal point 1 place to the right. So the decimal place starts here at the end. We got to move it 1 spot over, fill this in with a 0. So we're left with 240 times 10 to the 23rd atoms times 1 mole over 6.02 times 10 to the 23rd. Why is that beneficial for me now? Well, now what I can do is I can cancel out my 10 to the 23rds. So I'm essentially left with 240 divided by 6. And if we do the simplification there, that's just simple division, and you get a final answer of about 40 moles. Okay? So key points to take away. When we're converting between moles and either atoms or molecules, we always use Avogadro's number. It depends what goes on the denominator based on our given. And then we want to watch out for our stoichiometry with our scientific notation, to make sure our exponents cancel properly. Let's do another problem together. This problem asks, how many molecules are there present in 2 moles of carbon dioxide? So again, start with my given, 2 moles of carbon dioxide, CO2, and now I'm going to convert to molecules. Remember, molecules is just used in this case because we're talking about CO2. It's not a single element. Like in the last problem, we were talking only about xenon. Now we're talking about a molecule, multiple atoms bonded together, so that's why we use the word molecules instead of atoms. Okay, so then we got to do our conversion using Avogadro's number because we're converting to molecules again. So I'm going to need to put in the denominator 1 mole so that my moles will cancel, 1 mole of CO2. And in the numerator, I'm going to need to put how many molecules are in 1 mole, 6.02 times 10 to the 23rd molecules. Okay. Now what I have is a simple problem where my moles of CO2 cancel, so I'm just left with 2 times 6.02 times 10 to the 23rd. Remember, leave the times 10 to the 23rd till the very end, but do the other multiplication together. 2 times 6 is about 12 times 10 to the 23rd molecules. However, this is not written in scientific notation. I can only have one number to the left of the decimal. So what I need to do is I need to move that decimal 1 spot to the left. And when I move the decimal to the left, it makes the exponent get larger. So I will become 1.2 times 10 to the 24th molecules as my final answer. One quick conceptual question. Does it matter what compound I have here? In either of these problems, does it matter what element? In this case, it was xenon, or in this case, carbon dioxide? No, it doesn't, because Avogadro's number is just a ratio of however many things there are for 1 mole. It doesn't matter what the thing is. So I could have replaced this carbon dioxide with dinitrogen oxide, N2O, oxygen, anything in the world, and it would still have the same number of molecules. However, we know from molar mass that they would have different masses.